Hey engineers, let's dive into the world of FRP coating, fiber-reinforced polymer, a material that's seriously changing the way we protect, reinforce, and extend the life of structures. First off, what exactly is FRP coating? Think of it as a super tough, corrosion-resistant shield, made by combining a polymer resin, like epoxy or polyester, with strong, lightweight fibers, usually glass, carbon, or aramid. When applied as a coating, it forms a composite layer that can handle harsh chemicals, moisture, and even mechanical wear way better than traditional coatings. So, where do you use FRP coatings? Honestly, pretty much anywhere you need durability and protection. You'll find FRP in water treatment facilities, acid storage tanks, pipelines, bridges, even inside swimming pools. It's a go-to for retrofitting old concrete or steel structures, especially when corrosion is a major concern. I've seen it used on everything from chemical plant flooring to sewer linings. If it needs to survive a tough environment, FRP is probably in the mix. Now, let's walk through how this stuff is actually applied. The process starts with surface prep. This part is absolutely crucial. I'm talking sandblasting, grinding, or acid etching, depending on the base material. You want to get rid of every bit of dust, grease, or old paint. A clean, roughened surface gives the resin something to really grab onto. Next comes the primer coat. This is usually a thin layer of resin that acts like double-sided tape, helping the final FRP layer stick tight to the surface. Then, the main event, laying down the FRP. Workers roll out layers of fiber sheets, then saturate them with liquid resin using rollers or brushes. The fibers are what provide the strength, and the resin binds the whole thing together. Depending on the design, you might see one layer or several, stacked up for extra muscle. After the layers are down, there's a curing stage, sometimes just at room temperature, sometimes with a little heat. Curing locks everything in place and gives the coating its famous toughness. Materials-wise, I mentioned epoxy and polyester resins, but there's also vinyl ester for extra chemical resistance. For fibers, glass is most common, but carbon brings even higher strength and stiffness if the budget allows. So why pick FRP coating? In my experience, it's all about getting a long-lasting, maintenance-light barrier that can take a beating. It doesn't rust, it shrugs off chemicals, and it adds serious structural strength. To sum up, FRP coating is a versatile, high-performance solution for protecting and reinforcing structures in some of the harshest environments out there. If you're facing corrosion, chemical attack, or just need extra durability, it's definitely worth considering. Thanks for watching. And don't forget, always suit up and follow safety protocols when working with these materials. Catch you in the next one.